Good morning, students. Hope you all are doing good. This is lesson number 2 of chapter Gravitation. Today we are going to learn about the Kepler's laws of planetary motion. Kepler gave 3 laws of planetary motion. First, every planet moves in an elliptical orbit with the Sun being at one of its foci. Second, the line joining the Sun and a planet sweeps out equal areas in equal intervals of time. And third, the square of the period of revolution of a planet around the Sun is proportional to the cube of the semi-major axis of its elliptical orbit. Kepler's first law. The orbit of the planets are ellipses with the Sun at one focus of the ellipse. As you can see in the inset. Also, we should know what is aphelion and perihelion. Aphelion is the point on the orbit farthest from the Sun. Perihelion is the point on the orbit closest to the Sun, as shown in the picture. And what are ellipses? The Sun is not at the center of the ellipse. There is nothing at the other focus. Actually, Sun is at one of the foci of the ellipse. Now, Kepler's second law. The line joining the planet to the Sun sweeps out equal areas in equal intervals of time as the planet travels around the ellipse. For example, as shown in the diagram, the area swept by the planet in this point and in this point, they both will be equal because of the time difference and the speed of the planetary motion based on near and being farther from the Sun. In other words, the area from one time to another time is equal to another area with the same time interval. All of the areas in yellow and peach have equal intervals of time. Acceleration of planets. Planets move faster when closer to the Sun because of the gravitational pull. Force acting on the planet increases as distance decreases and planet accelerates in its orbit. Planets move slower when farther from the Sun. Coming to the Kepler's third law, the closer the object is to the Sun, the faster its period of revolution. That is, T square is directly proportional to A cube, where T is the orbital period in years and A being semi-major axis in astronomical unit.
Kepler's law of planetary motion. Kepler's first law. The orbits of the planets are ellipses with the Sun at one focus of the ellipse. There is no object at the other focus of the planet's orbit. The semi-major axis A of an orbit is the average distance between the planet and the Sun. As a planet travels in its elliptical orbit, its distance from the Sun and speed vary. A planet moves most rapidly when it is nearest the Sun or at perihelion. A planet moves more slowly when it is the farthest from the Sun or at aphelion. Kepler's second law. The line joining the planet to the Sun sweeps out equal areas in equal times as the planet travels around the ellipse. This is also known as the law of equal areas. Suppose a planet takes 1 day to travel from point A to B. During this day, an imaginary line from the Sun to the planet will sweep out an area. The same area will be swept every day. Here, the areas A1 and A2 are equal and the time T1 and T2 are also equal. Kepler's third law. The ratio of the squares of the revolutionary periods for two planets is equal to the ratio of the cubes of their semi-major axis. T square is directly proportional to R cube. So, T square by R cube is equal to Kepler's constant. Recapitulation. Kepler's law of planetary motion.
So students, based on what we studied today, here is your homework.